Yo, 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 what's up, lads? One sec. Oh, wait. Yo, we can't say those words, bro. We can't say those words. Number one. One second, I'm getting my camera to do the background thingy. Okay, should be good. Yo, 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 lads. Howdy, howdy. Howdy, ho. Okay, howdy, everyone. Hope you guys are doing well. Today is another great day to do some blue team stuff. Blue team stuff. Autocorrect V. What? Gonna be so yup, number one. Autocorrect V. Yeah. Yeah. Lads, yeah, like lads is like guys. Lads is basically like guys. Hey guys, how you doing? I watch a lot of British YouTubers, so that's why I keep on saying lads. That's probably the reason. Okay. Well, hope you guys are ready for no, not ladies, lads. Not ladies, not ladies. No, 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 no. But yo, good thing for you guys. Maybe you guys might want to hear this. We are at 704 subscribers. We still have like 12 days left. Yeah, we have 12 days left. 704 subscribers, and temperature today is minus 12 or minus 20. Sorry. So if you guys want me to jump in a weather like this, make sure you hit that 750 subs. Okay, so let's get started with our daily activity of protecting AOC, protecting the SOCMUS at Wherewell. You guys have your VM ready? Your pages ready? Let me know in the chats, and I will have water ready. Lead code. I'll do lead code today. Yes, I will be doing lead code today. Because of work, I've not been able to from last 2 days, but today I will be doing lead code because it's Friday night. I'm more free. So we'll do two lead code problems today. Cover up on a previous one. Don't worry. Okay. But yeah, with that being said, let's get started with our Advent of Cyber. Day 19, ICS Modbus Claus for concern. Learn to identify and exploit weaknesses in ICS system. To move faster, what I have done is I've already got the Brave out with the machine, right, and everything ready. So hopefully you guys are also on the same page. Get it done, right? As we go through it. Swap the timings, bro. Hacking in the morning and lead code and dude, I actually swapped the timings earlier because majority the reason I started this was hacking. So hacking is like my main. But lead code I can do a bit earlier if you want. A bit early in the morning for you guys. If you want that, I can do that. It would be like around your 7 a.m. or something. Or I can do around those timings if you want. Let me know in the Discord we can chat more and like do a poll about it. 8 a.m. class. So how about lead code at 6 a.m. or 6:30 a.m. We can do those. Okay, sounds good. I'll start doing lead code early. That'll be nice. Okay. Actually, that might work better for me because I will have I don't have meetings around that time of you guys. I just have meetings around like my 8 a.m. So that's like your 9:30. Okay, so that's actually good. That works out well. Okay, so With that being said, let's get started with our story. Let's lock in and get this out of the way. Day 19, Task 1 Introduction. The story. The snow falls heavily over Wareville. As chaos erupts at TBFC's headquarters, what should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg? Shouts a frustrated warehouse worker, holding up yet another Easter themed package. We were supposed to be shipping Christmas presents. The delivery drones buzz overhead, their mechanical hums sounding almost mocking. Each one returns from its route empty, having successfully delivered its cargo, but the cargo is all wrong. I will do it on the weekend. I'm just trying, bro. Sorry, but because so many things have been going around so much, I will try to get it done on the weekend. This weekend, hopefully, I will have more time. So yeah, I'll try it. I promise. It's just so many things are there on the plate. Okay, sounds good. Okay, so you are called into the command center where the screens flicker with delivery statistics. Everything looks normal to the surface. Thousand presents in stock, 98% success rate, and all systems are operational. But the phone won't stop ringing with confused citizens asking why they are receiving chocolate eggs instead of toys and gifts they ordered. The logistics manager pulls up a delivery manifest. Look at this, she says, pointing at the screen. The system indicates that we delivered a teddy bear to Miller family, but they received a chocolate bunny instead. It's the same weight, exact same dimensions, but completely different items. Then on one of the monitoring screens, a message flashes for just a second before disappearing. Exploit 6.66, property of Hopsec Island. Why should Christmas have all the fun? King Malhari. So someone has compromised the drone's fleet's control system. The attack is sophisticated, falsifying sensor data, manipulating inventory selection, and erasing all traces. This isn't just a prank; it's a calculated assault on Christmas itself. Your mission is clear: investigate the TVFC's drone delivery system, uncover how King Malhare's exploit team has compromised it, and restore Christmas deliveries before Sockmas is ruined. Why is Rabbit Bhavi? But we won. King Malhare doesn't leave systems undefended. Traps are waiting for the careless investigator. One wrong for the a careless investigator, one wrong move, and you might make things worse. Doesn't leave system. Okay. A mysterious discovery. As you walk through the warehouse controls room, something catches your eye. A crumbled piece of paper on the floor near the PLC terminal. What is PLC? Programmable logic controller. A programmable controller is an industrial computer that has been rugged, ruggedized and adapted for the control of manufacturing processes such as assembly line machines, robotics devices, or any activity that require high reliability, ease of programming, and process fault diagnosis. Okay, that's interesting. It looks like someone dropped it in a hurry. You pick it up and unfold. The handwriting is hurried, almost frantic. TBFC drone control register map for maintenance use only, holding registers, package type selection, Christmas, chocolate eggs, Easter baskets. Delivery zone 1 to 9 is normal, 10 is ocean dump. System signature, default, current. Check this. Okay, thank you, Robert. I'll look into that. Coles Boolean, so inventory verification, protection, emergency. Okay, audit logging, Christmas restored flag, Self-destruct status, never change HR0 while C11 is true, will trigger countdown. Maintenance takes December 19. So HR0, never change this when protection C11 is true. Okay. You stare at the note, confusion washing over you. Register map? Coils? What is all this? Terminology in is foreign. HR0, C11. These are probably flagged. Modbus scribbled in the margin. But something about it feels important, like a key you don't yet know how to use. You pocket the note carefully. I'll figure out what this means later. You think, for now, you need to understand the systems you are dealing with. Little do you know, this crumbled note will exactly what saves the Christmas. Learning objective, how SCADA, supervisory control and data acquisition system, monitor industrial processes. SCADA is one of those systems that is, like, if you understand SCADA, if you learn about SCADA very well, that is very valuable skill, because SCADA is like, let's say, dams, right? Those type of industrial level things, those infrastructure. This is what comes into play. This type of system helps manage those dams, those big infrastructure projects. What PLC, programmable logic controller, do in automation? How the Modbus protocol enables communication between industrial devices, how to identify compromised systems configurations in industrial systems, techniques for safely remediation compromised control system, understanding protection mechanism and trap logic in ICS environment. What is ICS? ICS denotes responsible for overseeing and conducting functions that support critical infrastructure like water, power, transportation, and manufacturing. So again, this is one of those systems that maintains critical infrastructure, just like SCADA. Connecting to the machine, we have our virtual machine today and our attack box we need to use. I have it open. That's what I would recommend. Get it started, right? Start your target machine by clicking start machine button below, right? And yada yada yada, just like us every day. The clock is ticking, investigator. Christmas is hanging by a thread, and only you can pull it back from the break. So pull out time. So we have today three tasks. One is task two is SCADA. What is SCADA? SCADA systems are the command centers for industrial operations. They act as the bridge between human operators and the machines doing the work. Think of SCADA as the nervous system of a factory. It senses what's happening, processes that information, and sends commands to make things happen. TVFCs use uh, TVFC uses a SCADA system to oversee its entire drone delivery operation. Without it, operators would have no way to monitor hundreds of drones, manage inventory, and ensure package reach the right destination. Is the invisible orchestrator of Christmas logistics. So basically, it's your nervous system of a factory, of the whole operations. Components of SCADA system. A SCADA system typically consists of four key components: sensors and actuators. These are the eyes and hands of the system. Sensors measures the real world conditions like the temperature, pressure, positions, weight, etc. Ac- actuators, actuator, actuators, actuators. How do you say it?
Actuators.
Actuators. Okay. Oh, thanks. So actuators perform physical actions: motors turn, valve open, robotics arm move, right? So all physical one. Okay, interesting. In TPFC's warehouse, sensors detect when a package is placed on the conveyor belt, and actuators control the robotics arms that load the drones. That's actually nice, like how they are working. Cool. Yo, Rover is number one now, lads. PLCs, programmable logic controllers. They- okay. These are the brains that execute automatic automation logic. They read sensor data, make decisions based on programmed rules, and send commands to actuators. A PCL might decide if the package weight matches the chocolate egg and the destination is zone 5, load it on drone 7. You will explore PLCs in detail in the next task. So basically, it's the brain. This is the nervous system. PLCs is going to control all the sensors and actuators. Okay. Monitoring systems. Virtual interfaces like CCTV cameras, dashboards, and alarm panels where operators observe physical processes. TBFC's warehouse has security cameras on port 80 that show real time footage of the packaging floor. These monitoring systems provide immediate visual feedback. You can literally watch what the automation is doing. Then we have historians, databases that store operational data for later analysis. Every package loaded, every drone launched, every system change gets recorded. This historical data helps identify patterns, troubleshoot problems, and in incident response scenarios like yours or ours, reconstruct what an attack did. So basically, historian is our log files, right? And monitoring system is just cameras to help us monitor things. So SCADA in the drone delivery system, there's a lot of learning happening today. But this is fine. This is actually, I think I like this way. At least we are learning something different. TBFC's compromised SCADA system manages several critical functions. Package type selection. So the system decided whether to load Christmas gifts, chocolate eggs, or Easter baskets onto every drone. This selection is controlled by a simple numeric value that determines which conveyor belt activates. So if you remember the first one, we had like the option, right? Or HR0, I believe. So that's what this is talking about. Delivery zone routing, each package must reach the correct neighborhood. Zone 1 to 9 represents different districts of Wareville, while Zone 10 is reserved for disposal. The ocean, a fail safe for damaged goods, but also a perfect target for sabotage. So, this is like the dump. Visual monitoring, CCTV camera feed provides real time observations of the warehouse floor. Operators can view which items can be loaded or are being loaded, verify the system behavior, and identify anomalies. This visual layer is crucial during the incident response. Inventory verification before loading a package, the system can check whether the requested item actually exists in the stock, just like Amazon, right? Where this verification is disabled, when this verification is disabled, the system blindly follows commands, even if those commands are malicious. So it will load things or gifts that are not even there, basically the eggs. I would be actually pissed too if I get instead of gifts, I'm getting eggs on Christmas. System protection mechanism. Security features designed to prevent unauthorized changes. When enabled, these protections monitor for suspicious modification and can trigger defensive responses. Unfortunately, King Malhari has weaponized these very protection as part of his trap. Interesting. Audit logging. Every configuration change, every operator login, every system modification should be recorded. Attackers often turn off logging to cover their tracks, and that's precisely what happened here. Why SCADA systems are targeted? Industrial control systems such as SCADA have become increasingly attractive systems or targets for cyber criminals and nationwide attackers. Here's why. They often run legacy software with known vulnerabilities. Many SCADA systems were installed decade ago and never updated. So that's actually the worst thing. Security patches that exist for modern software doesn't exist for these aging systems. This is same thing I'm doing right now in real world, right? For my job, like working on something very old, and those legacy softwares are not good. And even the banking system are like these. They work on very ancient old technology. Default credentials are commonly left unchanged. Administrators prioritize keeping systems running over changing passwords. In the industrial environments, the mentality is often if it works, don't touch it, a recipe for security disasters. True in both ways. They are redesigned for reliability. See, all good, boss, all good. Thank you so much though for coming, man. Yes, yes, I'll try my best. These are designed for reliability and not security. Have a good night, bro. Most SCADA systems were built before cybersecurity was a significant concern. These were intended for closed networks that were pre-assumed safe. Authentication, encryption, and access controls were afterthoughts at best. Okay, make sure you are straight too, bro. And I'm very happy to see you have started saying sorry and everything. It's nice. I corrupted your file. They control physical processes. Unlike attacking a website or stealing data, compromised SCADA system has real world consequences. Attackers can cause blackouts, contaminate water supplies, or even, in our case, sabotage Christmas deliveries. Be straight, bro, be straight. They're often connected to corporate networks. The myth of air gapped industrial systems is largely fiction. Most SCADA systems connect to business networks for reporting, remote management, and data integration. This connectivity provides attackers with entry points. Protocols like Modbus lack authentication. Many industrial protocols were designed for trusted environments or designed for trusted environments. Anyone who can reach Modbus port 502 can read and write values without providing their identity. So that's actually very bad. Like, and Modbus protocol, I haven't played with it yet. Has anyone played with Modbus protocol yet? In the early 2024, the first ICS or OT malware, Frosty Goop, was discovered. The malware can directly interface with industrial control systems via Modbus TCP protocol, enabling arbitrary reads and writes to device registers, often TCP port 502. King Malare has weaponized these same tactics not to cause blackouts but to sabotage Christmas delivery by directly manipulating the control system through Modbus protocol. In the next task, we'll explore PLC, the components that's actually compromised. That's oh wow, they have a full report. And why I feel like I have seen for this name before. Was it a very big deal that came out? Maybe, right? I feel like I have seen this one or something like this thing. Whatever. Here you go, guys. Have a wonderful PDF read later on. What's the port that's commonly used? 502. And maybe Frosty Goop, like we can just look. I want to see the CVSS score. Oh wow, it is 10, I think. Maybe? Oh. Hmm. That's crazy. How bad was. Oh, it's 600 buildings in Ukraine during sub-zero temperature. Oh wow. Heating system for 600 apartment buildings during January, causing a 2-day outage. That's really crazy. That's why I've heard it because like things like these, the news were like these were coming. Yeah. Wow. That's crazy, man. Okay, now with that, that's what we read. Now let's look into what is PLC. PLC and Modbus protocol. A PLC, programmable logic controller, is an industrial computer designed to control machinery and processes in real world environments. Unlike your laptop or software, PLCs are purpose built machines engineered for extreme reliability and harsh conditions. So basically, like your computer is a general purpose. You can play games on it, you can like build softwares on it, you can do hacking on it, you can watch movies on it. PLCs, these type of programs are specifically designed for one task only, but with only one thing in mind: high, very, 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 very high reliability, right? And they can work. It's almost like um, just having one computer just for like making videos, just related to video related. One is just for gaming, right? Optimized just for gaming or optimized for just very high computational, very less storage, stuff like that. This that what you see during when you are in cloud. Those are things you can see. PLC are designed to survive harsh environments. They operate flawlessly in extreme weather conditions, constant vibration, dust, moisture, and electromagnetic interference. A PLC's controlling warehouse robotics might endure. What's up, Idor? A very good morning or good day to you, boss. No, don't say bye right now. Stay for a bit. This is actually interesting. Have a look at this one, man. You probably know about this, but have a look at this one. That's some. This is a good one. You need to look at this day. I didn't say about any of the 18 days before, but this is a good day. Have a look into this one, man. Day 19. So, as you were saying, a PLC controlling warehouse robotics might endure freezing temperatures in winter storage areas and scorching heat under packaging machinery. Run continuously without failure, PLCs operate 24/7 for years, sometimes decades, without rebooting. Industrial facilities can't afford downtime for software updates or system restarts. When a PLC starts running, it's expected to keep running indefinitely. So, execute control logic in real time. PLCs respond to sensor inputs. Yeah, thank you, man. Yeah, you will love it. It's actually like one of those rooms where I learned stuff. Unknown, what's up, bro? Execute control logic in real time. PLC responds to sensor inputs within milliseconds. When a package reaches the end of the conveyor belt, the PLC must instantly activate the robotic arm to catch it. These timing requirements are critical for safety and efficiency. I'm doing good too, man. Thank you so much. Thank you. Have you worked on this room yet? A great room, man. This is a great room. I will tell you, I'm going to post in TryHackMe after this. Like, this actually room was good. There was some really crazy good learning. Interface directly with physical hardware. No, no to what? Oh, yeah, just do it with me. It's really nice. Interference directly with physical hardware. PLCs connect directly to sensors, like basically all the sensors that we have, and actuators, right? Yeah, they speak the electrical language for of industrial machinery. Interesting. I'll have to do it from day 5. Do this one. You can just do this one. Oh, exams end tomorrow. Oh, okay, nice, bro. All the best, man. Yeah, ICS is actually like, and especially Rover, where you live, you might actually have a good chance there because there, if I'm not wrong, there are ICS related opportunities there, and some universities support exactly that, like courses for it. Yeah, yeah, yeah. I remember because like I talked to somebody. I think there was this is the professor name. This guy. Really smart guy. Had a chat with him because I was going for my masters, and yeah, this guy has actually like wanted to build stuff related to it. These ICS system. I don't know why the image is not coming or anything is not coming. No idea. But that guy was actually like really smart about it. What's this? Oh wow. Oh wow. Beautiful. Damn. Yeah, you will get like good job here and well paid one too. Pretty secure. Nice. Nice. Yo, this is it, man. And they just ask them like, hey, are you looking for someone? I'm interested in this. Would love to know what you want or like how I can get started. Amazing stuff. Okay, going back, right? What is Modbus? Modbus. Modbus is the communication protocol that industrial devices use to talk to each other. Created in 1979 by Modi Khan, now Schneider Electric, is one of the oldest and most widely deployed industrial protocol in the world. Its longevity isn't due to sophisticated features, quite opposite. Modbus succeeded because it's simple, reliable, and works with most devices or almost any device. Think of Modbus as a basic request response conversation, a client server architecture where your computer PLC was the current value of register 0, or like what's the current value of the temperature outside. The server, the PLC register 0 currently holds this value, right? You are going to ask PLC, which is connected to a sensor, that hey, what is the temperature outside? PLC will get the value from its sensors and have it giving to you. Oh, a question about the giveaway. The THM is doing for the what? Doing for the OSCP exam? I didn't get that, bro. And actually, Rover is sponsoring that giveaway. So big thanks to Rover. This simplicity makes Modbus easy to implement and debug, but is unknown. Write a question again. I didn't get it. Like maybe then I can help better. The simplicity make Modbus easy to implement and debug, but it also means security was never a consideration. There's no authentication, no encryption, no authorization checking. Anyone who can reach the Modbus port can read and write any value. It's the equivalent of leaving your house unlocked with a sign saying, "Come in, everything is accessible." That's basically Canada. Modbus data types. Modbus organizes data into four distinct types, each serving a specific purpose in industrial automation. So we have coils, digital outputs, zeros or ones, motor running, valves, alarm system active, discrete inputs, again 0 to 1, digital inputs, button pressed, door closed, sensor should be triggered. Oh, THM is doing 50 BSCP exam. Okay. Yo, send the link in the Discord. That'll be nice. Thank you, man. I don't know. Send the link and I will also look into it. After we do this room, we'll look into it. Okay. So now, third register is holding registers, or third, what's this called? Purpose types, right? Holding register, analog output, temperature set point, motor speed, zone selection, which zone, 0, 1 to 9 or 11, right? Then we have temperature. It could be in Kelvins, or 233 would be the 0 degrees, right? Input registers, analog input, so opposite of this. So we have input output, coils, discrete inputs. Now we have holding registers and input registers. The distinction between inputs and output is important. Coils and holding registers are writable. You can manage their values to the control system. Discrete inputs and input registers are read only. They reflect sensors measures that you observe but cannot directly modify. In TBFC's drone control system, you'll find holding registers storing configuration values, HR0 package type selection, which package to select. That's where you are like reading, right? Holding registers. Delivery zone, system signature, right? A version verified, or in case attackers calling card. Burp suite, web security, burp suite. Oh, okay. I'll have a look. Next is coils controlling system behavior. So again, reading inventory verification, enabled protection mechanism, emergency dump control, audit logging, blah blah blah. Remember that crumbled note you found earlier? Now it makes complete sense. The maintenance technician was documenting these exact Modbus addresses and their meanings. Modbus addressing. Each data point in Modbus has a unique address. Think of it like a house number on a street. What you want to read or write a specific value, you reference it by its address number. Critical detail. Modbus addresses start at 0, not 1. This zero indexing catches many behaviors off guard. When documentation mentions register 0, it literally means the first register, not the second. Examples from TBFC system: hold register 1, hold register 4, call 10, 11, 15. The reason they keep on going back, I think this is what all we will be playing with. How much more is left? Bro, there's so much. I like that we are reading, but holy. Oh, okay, stretching a bit. Let's get started back again. Modbus TCP versus serial Modbus. Originally, Modbus operated over serial connections using RS-232 and RS-485 cables. Devices were physically connected in a network, and this physical isolation provided a degree of security. You need physical access to the wiring to intercept or inject commands. Modern industrial system uses Modbus TCP, which encapsulate the Modbus protocol inside standard TCP/IP network packets. Modbus TCP servers listen on this. So earlier it was all wires, you have to go in and all those physical access, but now the world has changed. This network connectivity brings enormous benefits: remote monitoring, easier integration with business systems, and centralized management, but also exposes these historically isolated systems to network based attacks. If you get access to the network, like their router and stuff, you can manipulate things. King Malhari exploited exactly this vulnerability. The TBFC drone control system Modbus port 502 was accessible over the network without any authentication required. He didn't need to break into the facility or tamper with the wiring. He simply connected to 502 and started issuing commands if he were authorized. Security problem: there is no authentication, doesn't verify, right? When who is making the request. No encryption is there, things are in plain text. It's like telnet. No authorization, so anybody can perform any level of work because there is not like a simple user or something big, right? And no integrity check. Thanks, Robert. Beyond checking stuff, right? There's no integrity check. Modern security solutions exist: VPNs, firewalls, Modbus security gateways, but they are add-ons, not part of the protocol itself. Many industrial facilities haven't impl- uh, implemented these protections, either due to cost concerns or compatibility issue with legacy equipments, or a simple lack of awareness. Lack of awareness is actually, and cost concerns are two big things, right? Connecting the dots. Now you understand why the OpenPLC web interface showed nothing useful. King Malhares bypassed it entirely. He connected directly to the TCP port and manipulated the registers and coils that control this behavior. Wait, uh, try again. If not, like send in. Maybe you can send in Twitch or Discord. I will have a look. What's that? That note you found, the maintenance technician must have discovered what was happening and started documenting the compromised value. The warning at the bottom, never change HR0 while C11 is true, suggests they figured out the trap mechanism before getting interrupted. In the next task, we'll use Python and py modbus library to investigate the system exactly the way King Malhere attacked it by directly reading and writing modbus values. Time to see what he actually changed. It's interesting. Python has everything. It's crazy. Now you understand the basic concepts related to ICS and Modbus. We will analyze the compromised TBFC drone control system and learn how to safely restore it. Initial reconnaissance. So, as with any incident response scenarios, we begin with reconnaissance. Let's discover what services are running on the target system. So, from the attack box, we'll do a nmap scan of the machine IP. Why we are doing 80? Because the interface was open at 80. 22 is for SSH, right? And 502 is the Modbus. So let's have a look. I don't want it full screen. This will work, right? You guys can see. And what is the IP of this guy? Okay. Also, I'll just quickly open Discord. I know. What was it did he send? So I can have a quick look. Oh, LinkedIn post about birdseed. Okay. Till that is running, let's read it. Complete day 17 to day 23 Advent of Cyber. That's all the days, no skipping. And you will be entered to win one of the 10 birdseed certifications, 7 days, 7 elite topics. Nice. So we are at ICS. That's good. So we have done all these. So that's good. So basically, do it and you will get it. Nice. You will get a chance. Race conditions, malware analysis, C2 detection, AWS security. Nice. Nice. That's my boy Sriram right there. That's Bupinkar, if I'm not wrong. No, somebody else. Oh, well, that's Umar. Yeah, yeah, I remember Umar. Yeah, yeah. Okay, nice. Thank you, man. Didn't know about this. Thank you. Okay, and now let's go back to our scan results. Still working. Guess who? Oh, you are? You are Umar? That's awesome. I remember seeing your message, man. Thank you so much. Thank you so much for that. I really appreciate the kind words. So thank you. Okay, and we have something interesting here. DNS servers, nmap report, and all this. Okay, so we at port 22 we have this. Port 80 we have Python running, right? With Mark Ziuk. I don't know, but it's a HTTP server. Yeah, thank you, man. And then we have Mob Modbus MB. This one, okay. Copy the value. So it is talking about the Modbus application protocol. So that's MB for Modbus and application protocol. Okay. Two services unrecognized despite returning data. If you know about these services, submit here. Okay. This is nice. We got something. Coming back. Service dissection performed. Please report any incorrect results to this. Okay, that's good. We got our stuff. So now, for in this case, we have the same thing, right? Modbus is running. We have this, and I don't know why it came as different for me, but yeah, at least we got the same results. We specified these three ports to speed up the scan. If you want to perform a comprehensive scan of all ports, you can do it, but there is no need, right? There is no need of performing this. Restream, I actually did. I will tell you reason I don't use it. I did use the Restream because of like they were asking for the payment for like a 180p 1080p what's this called output. I could only do 750 for them, 720p for through them, and there were those were the reasons basically. I can't have really good quality videos, and there is like time limits also coming up and all those. If I'm remember correctly, like time limit was also a thing with them. That's the reason I didn't go for Restream. Is good. Restream is good, no doubt. I did it, but it's because of the quality. I could not do much. Yeah, that's why I looked at. There was a Restream. There was a Duck one too. I forgot the name. Similar services. Yeah. I'm going to change this. Like so, the things come in one go from both the sides. There is like less censored stuff. I just didn't get time because of the new project I have from work. Yeah, hopefully soon. Hopefully soon. Okay, going back, right? However, this will take significantly longer, and as it scans all the 65,000 ports, right? What we need is port 80 502, right? We know that now. We saw that CCTV feed is there and PLC communication protocol is there. I'm trying to work on that less censored stuff, right? So hopefully this is typical for an industrial control system setup, a web interface for monitoring and Modbus for programmatic control. Visual confirmation, the CCTV feed. Before diving into technical details, let's see what's physical what's physically happening in the warehouse. So when we go here at the machine IP, oh hell yeah, I want to see that. Can't go up. Interesting. Copy. So we have our Firefox running. Port 80. Let's see. Oh, they changed things. Interesting. Because earlier I remember they had like you can't stream in 180 or like full HD. But storage or recording, okay. I'll look again then. Status compromised, and we can see the industry like camera here. I'll look into that again. They might have changed because I used Restream I think 2 years back, almost 2 years back. That was actually one of the very first things I looked. Yeah, the reason I looked into Restream because I during that time I didn't have a good what's it called computer, so I needed like a third party service where I can stream instead of like having through Twitch as well as YouTube. So that's actually has changed, so that's good. I'll look into it. Thank you so much, lads. I'll look into that again. Okay. Through the security camera, you can see the warehouse floor in real time. Robotic arms are busy at work and the conveyor belts are running smoothly, but something is wrong. Instead of Christmas presents, what we see is pastel colored chocolate eggs being sorted, Easter themed packaging on the assembly line, and delivery drones are loading eggs instead of gifts. The status display in the corner says compromised, right? It was saying system has been compromised. This visual confirmation tells you the problem is real and active. The system isn't broken, it's working perfectly, just delivering the wrong items. This is classic sign of a logical manipulation attack rather than the system failure. So things are working fine is because of the system inside data has changed. They are manipulating the logistics about it. Keep the CCTV feed open in a separate tab. It will update as you make changes to the system, providing real-time feedback on your remediation efforts. Modbus reconnaissance. So we'll need to interrogate the Modbus server directly. There, this is where Python and PyModbus library becomes essential. Remember that crumbled note you found earlier? Pull it out now. The terminology that seemed foreign, all these one, is about to make a perfect sense. Step 1 to 5 are optional and you can just read along with us. So install PyModBus. That's I think on the attacker is probably installed already in the attack box. So pip3 install this if you guys want to do it on your own. It gets downloaded. Establish the connection. So we open PyModBus client, import Modbus TCP client. In the client, we give the IP of the machine and the port, and then we establish a connection connected to the PLC successfully or the connection failed, right? Excellent. You have a connection to the PLC Modbus interface. Notice that no authentication was required. When you are doing with SSH, you have to provide the username and password if those are what's this called enabled, right? With SSH, it's mostly there, and with anything else. But here in this, you're just providing the IP and the port. This is a critical security weakness in the Modbus protocol. Reading holding registers. Holding registers store numeric configuration values. According to the note, HR0 controls package system selection. Let's read it. Result is client.read holding register. So we have address 0, 1, slave 1, right? If not result, if result.is error is like not result.is error, there is no error. Package type is this HR0, right? If package type is 0, Christmas presents, chocolate eggs, blah blah blah. We have HR type HR0, the value inside it as chocolate eggs. So we that's what we need to manipulate. There it is. HR0 is set to 1, which means the system is configured to load chocolate eggs, not Christmas presents. The note was right. This is exactly what's causing the problem. Let's take HR1, the delivery zones. If there is error, right, as long as there is no error, zone result.register at 0, registers 0. So H1, HR1, if zone 10, warning, ocean dump zone, or normal delivery zone. So zones are still normal, which is good. Now let's take H4, the system signature. Same thing, connecting the client, address is 4 this time. It's earlier here it was 1 and here it was 0. So signature result.register H4, signature 666, exploit detected, King Malhare signature. Hmm. So their system signature is this. We need to change that as well. Because system signature has a value 666, confirm the system has been compromised by the exploit framework. This message, the taunt message we saw earlier, exploit version 6.66. Reading coils. Coils are Boolean flags, zeros or ones, that control system behavior. The note mentioned several critical ones, right? So we have coil 10, disabled. System is not checking the stock, it's just sending all the things. Inventory verification is disabled. The system is blindly following the commands without checking if the items actually exist in the stock. Here we are reading coils again, but this time it's the coil 11. That was for protection and override and active. Changes are being monitored. When anytime somebody makes a change, it's being monitored. This is crucial. C11 is enabled, which means the system is actively monitoring for changes. Remember the warning, never change these two registers together. When C11 is true, do not change HR0. It will trigger a countdown, things will stop. So we need to first turn it into false and then back true again. Coil 15, self-destruct is armed, not armed yet, safe for now. That's the good news. Things are not going to self-destruct, the whole system, PLC system, but it will if we try to change HR0 with C11. Understanding the trap. HR0 is 1, C11 is the protection. So we need to first change C11 to false, then HR0, then C11 back. If someone changes them together, C15 will be armed. So we need to make sure, and we have 30 seconds to make sure that, right? The technician warning was trying to save whoever found this note from making things worse. Complete reconnaissance script is here. We will make a reconnaissance.py file, right? Let's create a comprehensive script to see the full system state. Exit Python interpreter. And then we have from Modbus. Okay. Unit ID 1. We connect to the PLC IP. And if we are connected successfully, reconnaissance report, holding registers. So it got all the values. Reading the coils is getting that. So all we read is just now in this. Okay. So whatever we read, they just put in one go. Now we have completed, we have a complete picture of the compromise. Time to restore the system. Based on your reconnaissance, we need to first disable the protection mechanism, change HR0 to equal to 0, enable inventory verification, enable audit logging, and verify C11 was never armed. The order is crucial, right? I think we have said that 20 billion times. So we'll create our restore Christmas, and we have this. So let's do that. So we have our Python file ready. Now what we are doing, let's read line by line and do it. Python 3, we are importing Modbus TCP client and the time. So we have the port machine IP we have to change. Read the coil we are reading. Address, whichever address we send to this, and then we have for registers. Connect to the PLC. We connected. It said the same thing. Verify the current system state. Package time. This client for this client, the PLC client we got, right? Check its register 0, which HR0, coil C11, and then C15 for armed. Then disable the protection C0, right? Or C11, sorry, to false. We are writing directly. If there is error, protection disabled, safe to proceed. If not, close the connection. Now that the protection is off, turn the HR0, right? The HR0 to 0 for Christmas. Enable inventory verification. To do that, again 10 to true because zeros and ones. And then enable auditing, C13 as true again. Verify the system has restored and the self-destruct is not on. And that's our, yeah. If Christmas restored and new package equal to type, not emergency dump and not self-destruct. Success. Flag result is address at 20. Count down this. Should we just get the flag directly? Do you want me to try to get the flag directly and see if it worked? If not flag, oh, it might give error. Okay. Registries, append this thing, append this. There is a lot more happening. So, okay. We'll just create this. We'll just do our Python file. Do you guys got what we were doing? Do you guys understand? Did it make sense what we did today? Hopefully, maybe. No. Okay, that's good. It is very interesting, no doubt. Yeah, it is very interesting because it's a change from our usual, right? Like we have a web server doing this, that. So I like this one. This day was a good one. So now we'll do Python 3. Oh, IP, I have to change the machine IP. What's the IP here? So package protection is off. Type is 1 for eggs. Protection is disabled now. Christmas was saved because now enabling. Now here we make the changes. Inventory enabled, enabling audit logging, enabled. So, and we change the values. Has been restored. The drones will now deliver presents, not eggs. Check the CCTV feed to see the result. So we'll go to our CCTV feed. System restored. Oh, that's actually a scary one. I don't like him. I don't like his face. I should put that on my ugly sweater. And now it's disconnected from PLC. That's also good. And that's our flag, lads. Nope, that's a lot of words. This flag. Here's it. And the flag. So I want to just see one thing. From the register in flag results or registers, flag result and all the dot registers. Okay. Append register, and then we have this. Those are the two lines I want to understand more. Excellent work. Now we check the CCTV. What if you triggered the trap? If you have tried to change the HR0 before disabling C11, here's what would have happened. Self-destruct immediately. 30-second countdown would begin. After 30 seconds, C12 emergency dump would activate. HR1 would change to 10. So all the things like the eggs or presents will go into the ocean dump. All remaining inventory will be dumped. CCTV would show the trap activation screen. You would need to restart the challenge. This demonstrates why understanding industrial control system before making changes is crucial. In real world, triggering safety mechanisms and traps would severe could have severe physical consequences. Post incident analysis, King Mahala's attack was sophisticated because it used unauthorized Modbus access, manipulated the configuration values directly at the protocol level, disabled safety mechanisms, implemented a trap, and left a signature as a calling card, as a taunting. The maintenance technician who left the note likely discovered the compromise but was interrupted before they could fix it. This documentation saved Christmas by warning about the mechanism trap. Congratulations, you successfully investigated and remediated an industrial control system compromise. You have learned how SCADA system works, probably not. How PLC operate, not much. How Modbus communication functions, little bit. And most importantly, how attackers can manipulate these systems and how to safely restore them. Not at all. Cool. So we have our flag, THM. sec. Okay, and we have industrial intrusion as one of the rooms. This is a team room, they said. Let me turn that off. Oh yeah, yeah. I did copied it wrong way. Let me do one thing. Uh, your only team achievements are displayed on the scorecard. Okay, so this is, I can still do it. It's a premium, but it's all the teams. Okay. The completion will run from this time. This is probably like a very old one. Interesting. Hmm. This is an old one, super old one. Damn. This was a good room. Did a lot. I just want to get two things done here. The line flag bytes append and these two are used to split 16-bit values stored in variable reg into two separate 8-bit stuff. Okay. So first append, make them 8 bits each. This is a common operation in programming where a larger data type needs to be stored or transmitted to 1 byte at a time, often related to hardware communication or specific data formats. Right shift, this operation shifts the bits of reg variable 8 positions to the right. So this is a 16-bit one, change to 8. Next, so whatever was the reg, it shifted 8 and then added 2 bytes. And then reg at this, there was a and happened. So that's all the first part what happened here. Now I understand. Let me just give you a quick idea if I got it right. This was 8 bits, right? So let's say 8 bits here. So 1 byte, 8 bits here, 1 byte. This whole thing is reg, right? What it did was, if you see the first one, right shift. So what it did, it moved all the values, all the bytes. Let's say if this was 0, 1, 1, 0, 1, 1, 0. So 8, no, that's 7. Let's say this, right? 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is how it looks, right? First operation, what it did, it shift all to by 8 bits to right, and all these get destroyed. So now this will become something like, all this will be 0 because all of them shifted right. So this part will come here. Where it is. Where can I change the? I'm not able to change the color. Oh, here it is. So all this, right? This part comes here. This is removed. So we get 0, 0, 0, 0, 0, 0. So 8 of them. and then we have 0 1 1 0 1 1 0 1, right? That's the first. Then we have second. In the second case, it had an AND operation with 11 bits. So what this is here are this had an AND operation, and with 8 bits. And this all because 8 bits, so if it is going against a 16 bit, so everything else will be 0. So if you know 0, 0 and 0 will be 0, 1 0 0. All this will automatically become 0, right? Only these ones will preserve whatever is their original state. So 1 1 0 0 0 1 1 1. So first byte will be looking like this. The first and second byte will look like this. That's what they did. Shift 8, shift right to 8 in the register, whatever the value came from register, and then this is all ones, right? In the first 8 zeros and 8 ones. And now they join all the characters of B in like this. If B is not 0, and that became the flag that came out as flag. That's interesting. They did a little interesting way. And they read from like registers. At address this, count 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh yeah, it is 12. It is 12. Because if you see, right, this value here, these are 12 characters, including these two. Was that helpful? Do you guys understand what I just did? Oh, it has rover almost in the end. Nice. Yeah, you did. Oh, that's good. Yeah, these are like bit manipulation is also a very interesting thing. Because you need to, like, I will say, if you want to get in cybersecurity and learn about encryption, XOR and or and then bitwise manipulation like these are not hard. Once you learn it, you will remember it forever. It's like very nice. So give it a read today, lads. I will recommend, a big recommendation. And it's 9:30. Time to go to work. Okay, lads. Yeah, that was it. So thank you so much, everyone, for joining me today. We completed another room, right? And also, we looked at the Burp Suite one, thanks to Mar Unknown, right? We looked at it and we were able to find that there will, if you do from day 17 to day 24, you will get a chance to get one of the Burp Suite certifications. Yep, corporate slave time. It's fun. It's fun to say that. Okay. But thank you so much, lads. Thank you so much for coming today. Completed day 19, keeping our streak. Hopefully, we complete the month with a streak of 30, right? At least 25 will be there, Advent of Cyber. But thank you so much, lads. Hope you have a great day. And I will see you guys in the evening for some lead code or die. Two of those. Till then, yes, your favorite corporate slave hacker signing off with a big bye. Time to do some slave stuff. Okay. Thank you so much, lads. Bye. And also, before you guys go, here is a song for you all, right? Hope you guys like it. You guys there? You guys there? You guys there?
Okay, I'll tell you what. Why don't we all grab our little anthro...
Have a look.
Day is never finished. Master got me working. Someday Master set me free.
Dude, shut up, Cartman! Oh, I think...
Day is never finished. Master got me working. Someday Master set me free.
Dude, shut up,
Have a good one, lads. If you guys enjoyed, this was your favorite singer, Eric Cartman. Enjoy. Okay, thank you so much, lads. This was your corporate slave hacker. Corporate slave about to go for some slavery. Thank you so much. Have a good day and give your loved ones a hug. This is your favorite, as mentioned by Rover, your favorite corporate slave hacker signing off again with a big bye. Thank you so much, lads. Have a good one.